welcome back again to this course on that means what we are talking about, the design compiler basic. So in the last class we have seen what? We have seen that okay, there are several methods for doing this design reuse or partitioning and all those things. We have seen there are different methodologies or design terminologies which are associated with design compiler. Okay. So now again another thing which I can do, that means we can do in design compiler, that means we can partition by compile technique. Okay. So partition these that means if there are several blocks only, if I am going to design a complex block, when there are several other sub complex block, then only I have to perform this partition on all these things. Otherwise for a simpler block all these things is not that much necessary. You can do, but that is not at all necessary. So this is necessary whenever we are designing a bigger circuit or we are designing a complex circuit. Okay. So partitioning by compile technique, it says that this partition logic that requires different compile techniques into separate blocks. Use this method when the design contains highly structural logic along with the random logic. So random logic is better suited for flattened design, and this highly structured logic such as error detection circuitry, which usually contains large exclusive OR trees, is better suited for structuring. Okay. So that means different blocks needs different partition strategy. Okay. So then again another technique is that means keeping the shareable resources together. Keeping the shareable resources together means suppose consider one circuit like this one. Okay. So if you look at this circuit, so first A, B, C, D, these are the 4 variables which are A and B, and C and D is that means added into 2 corresponding adders. Then based on this control parameter, they are being output of these 2 has been selected and fed to a register. Okay. But here you see actually it needs 2 adder and 1 multiplexer. So instead of doing that, that means here the area complexity is 2 adders and 1 multiplexer. So obviously we know that if the bus width is more, at that time adder area will be more than the multiplexer unit, right? So instead of doing that, okay, to reduce the area, that means requirement, what I can do, I can initially, that means here I can, that means I can use 2 multiplexer first to enable the 2, that means input, like between A, we choose between A and C, and then in the next multiplexer B and D, so that using 1 adder I can do the same task. Okay. So here what will happen, if the control input is 1, so at that time it will choose A from the first multiplexer, B from the next multiplexer. So that adder will add A and B, and it will be fed to the corresponding registers. So in the next, if control input is 0, so at that time it will select C and D as 2 of these inputs. So C and D will be added and it will be fed to the register. That means I am implementing the same logic, but here my area requirement is lesser than the earlier one. Okay. So what we are doing, we are keeping the shareable resources together to enhance the performance of the circuit. Okay. So then HDL coding for synthesis. What I said, a good coding practice can give you a, that means better in terms of compilation, that means requiring compilation timing or any other thing, optimization or for during the synthesis process. Okay. So HDL coding is the foundation for synthesis because it implies the initial structure of the design. So when writing your HDL source code, always consider that the hardware implication of the code. A good coding style can generate smaller and faster design. Then again that means this you have to write the corresponding HDL code independent of the technology. That means the corresponding HDL that will be written in a generic way. That is not at all, that means when it will be technology dependent, that means if I am using like, that means I am coding into the gate level representation, like I am using AND gate, I am using OR gate, I am using some other gates. So at that time it becomes too much of technology dependent. That means I am using the cells from the library or these basic gates from the library, and then I am describing those into my corresponding HDL description. But that is not at all that means good coding practice, because suppose I am using or I want to, that means change my technology. So at that time those library will not be used for that particular, or those information will not be used in that particular technology. So that means if I want to change, that means interchange from one technology or upgrade from one technology to another technology, at that time I cannot do. So that's why you have to write technology independent HDL file. Okay. So this inferring components. So inferring component means I can infer several components using the comments in design compiler. Like if I want to infer a multiplexer, so using this marks underscore OP, I can infer one generic multiplexer cell, which basically actually that means just by in the HDL code, just by writing this marks underscore OP, I can infer a general multiplexer code. So and if your target logic library that contains at least a 2:1 multiplexer cell, design compiler maps the infer marks.ops to multiplexer cell in the target logic library. Okay. Then again this I can infer a register, I can, that means infer the register without control signal, I can infer the register with control signal, that means D with enable, D with preset, D flip flop or any other flip flop with preset, enable. These are the control signals which are available to the flip flops. So with those control signals or without control signals also I can infer. Okay. Then again I can infer these 3-state buffers, then I can infer these multi-bit components. All these things I can infer through writing that things in the HDL code in the design compiler. So using a HDL construct. So again a good coding practice, like suppose you consider this sensitivity, that means this Verilog code, always at the rate of A, C equals to A or B. So here you see this is a purely combinatorial circuit. So here C will be changed, that means C is assigned based on the values of A and B. So in Verilog, sensitivity list provides what? It basically provides the sense, or it senses the changes which is occurred, which variables are listed in its sensitivity list. So here you see C basically that will be changed or that need to be changed based on the change on A on B, both of the variables. But in the sensitivity list I have mentioned only one of the variables. So that is not at all a good coding practice. I have to, that means it will give you erroneous result. So that's why this is not at all a good coding practice. So you have to, this is incomplete sensitivity list. So you have to complete the sensitivity list by mentioning the B also. That means always at the rate A or B, C will be assigned as B, A or B. Okay. So then value assignments. So value assignment means there are two type of assignments, like blocking assignments and non-blocking assignments. So the hardware generated by delayed value assignments implemented by Verilog non-blocking assignments, and in VHDL is independent of the ordering of the assignments. Okay. So use delayed assignment with sequential Verilog always blocks or VHDL processes. Use immediate assignments, or which is blocking assignments with combinatorial Verilog always block or VHDL process. That means always block means, so here when I can use always block, using always block, that means there is a behavioral description in of HDL language. So whenever I am defining the behavioral description of a combinatorial circuit, so at that time I have to use this immediate assignment. That means whenever there is a change in the input, obviously the output will be reflected by that. Okay, so that means this immediate assignments, which is the blocking assignment as in Verilog. So this delayed assignment that are basically mentioned, that means required for sequential element, where it is needed a latch operation or it is needed a registered operation. Okay, so that's why we have to use, that means though we are using the always block, so at that time I have to the syntax for that in a non-blocking assignments. Okay, so these are the good coding practice. So like another good trading that means good coding practice is that if statement. So whenever one example is that this if statement is that if a equals to 1 ampersand and then b equals to 1, that means this is the logical equals and logical and. Okay, so that means within a if, to perform this operation, okay, it creates a problem. Okay, so that's why it will be much more, that means for a good coder it will be, that means this assignment, that means or this condition, that will be assigned in another variables, and then if will be covered within that. Okay, so that's why this this if statement is incorrect. So then again this constant definition. So how we can define the constant values using Verilog. Then this case statement. Okay, how we can define a case statement. Okay, so there are that means various method for a good coding practice for in Verilog or VHDL language. So this macro definition is, that means if we are using this define statement, so at that time we have to be very much careful about that. That means what we are defining, whether we are defining that means constant values or we are defining any other thing, that we have to be very much cautious about. So that means writing an way of effective code. So effective code means basically suppose if I designing a 1000-line codes, so at that time we have to, that means put some suffix meaning. So suffix meanings means, suppose one clock, there are 10 clock nets. Okay, I am assigning. So at that time those clock nets will be suffixed with underscore clock for clock signals. So underscore clock, it indicates that okay, those are the clock signals. Then underscore next, the signals which are being used for registering. Then underscore n is basically used for active low signal. Underscore z is the signal that connects to a 3-state output. So that means these suffixes are basically helps to that means for proper that means identifying of the proper meaning of the signal. Okay, so this extension using this suffix itself, it means that what type of net or what type of signal is this one. Okay, then these guidelines for expression. So whenever we are that means defining a logic expression, so at that time suppose like one example is that a bus select that is equals to A XOR B and C invert XOR D or B. So we have to put the parenthesis in between. Okay, like A XOR B is one operation, so it will be put in a parenthesis. Then C that means invert of X, that means XOR D, that is another operation, so that will be put in a parenthesis. Then whole operation will be put in another parenthesis. So this is a good coding practice. Okay. Otherwise, whenever we will put that this logical expression into the that means the design compiler, so at that time it may interpret as a different expression and it can gives you a different netlist file than the desired one. Then the guideline for function that means calling also is there. That means the function will be called by its specific, the function first, the thing is that function will be named properly, then the function will be called properly by its whatever name we have given. Okay. So whenever that means this as I said that there I need this clock gating circuit, or this for power saving I need any, that means register retiming for improving the timing information. So there are several other functionality which might require the component instantiation or functional implication, like this that means if I am getting a hazard in, that means that is this static hazard or this any other kind of hazard. So at that time I have to use asynchronous logic. Okay. So and then so many of this functionality of that means which requires this kind of things are like this multiplexer, memory elements like RAM, ROM, and then macro cells. These are require this kind of that means component instantiation or this functional implication. So then this after that means preparing the HDL file, what we have to do? We have to give the information about the library, right, to the design compiler. So the design compiler library information that can be, that means given to the design compiler. So the logic library means where the basic gates will be there, the information about the basic gates will be there. Okay. So using this link underscore library we can specify those library. Okay, this is my that means logic library, so please link to this particular library. Okay. So then we can do that means okay, in this basically this logic library, what will be there? In this logic library there will be this unit definition, operating conditions, like operating condition means the information about your process voltage and temperature information, then the K factors, then the well load model selection, then the input and output voltage, then the timing range, then the RC slew trip point, then net transition time degradation table. So that means all this information will be there in the library for each of these components. Okay. So then after that you have to do this target library. So what is your target library? Okay. That means in which technology I am going to implement my circuit. That may be, so there are several foundry like TSMC, UMC, and then Austria Microsystems. So several foundries are there. So in which foundries I am going to fabricate my chip, so that is basically known as target library. So that means though if I want to fabricate my system using TSMC library, so at that time my target library will be TSMC. So the TSMC will provide me the corresponding library cells, standard cells as the logic library or as the target library, so that whenever I will design my circuit or I will implement my circuit, so I will implement using those. So I cannot fabricate, after implementing I cannot fabricate it using UMC. Okay. I have to fabricate with the TSMC foundry itself. Okay. So using this target underscore library variables we can mention what is the target library, or we can specify the target library in design compiler. So, link library already I have said, and then another thing is that another that means variables which we can put, that is search underscore path. Search underscore path variables specifies a list of directory paths that the tool uses to find logic library and other files when you specify a plain file name without a path. Okay. So, that means suppose I kept all this library information or all this library into a single, that means directory or into a path. So, if I that means mention in the tool that okay, my library search path is this one, and you find this library, so automatically it will go to that particular directory, it will search and it will include those particular library into, or it will just incorporate those library into the design vision environment or design compiler environment. Okay. So, then again symbol library. So, symbol library is required. Symbol library contains the definition of the graphic symbol that represent library cell in design schematic. That means this the semiconductor vendors maintain and distribute the symbol libraries. That means the adder, the symbol of the adder. So, whenever I will use that, so in the schematic mode it will show me the symbol of adder. Okay. So, for that reason I need to use the symbol library. So, if I am using a divider, so it will give me this the symbol for divider if it is available in the library only. So, we have to mention that okay, symbol library is this one, we have to mention that. Okay. So, and this the format or this, that means the corresponding extension for symbol library is .sdb, and for logic library the symbol, that means the extension for logic library is .db in Synopsys. So, Designware library. So, Designware library is that means as I said that suppose I am using that means this procedural statement or something like data flow level modeling we are using. So, there what we do, we use maximum time we use this assign statement. Suppose I want to design a multiplier. So, what I will do, I will say that okay, assign product equals to A star B. Okay. So, A star indicates itself that it requires a multiplication operation. So, whenever I will put that expression into the design compiler mode, so at that time how this multiplier will be converted, because that multiplier is not at all that though I have used that means the logic library. So, in the logic library I will have only the basic gates like this AND gate, OR gate, AND or invert, something like that, or NAND or D flip flop, something like that. But I do not have the corresponding multiplier itself. So, at that time what will happen in a design library, Designware library, it provides all these operators like plus, minus, adder, subtractor, then multiplier, then shifter, then this comparator, all these things. So, whenever I'll just assign those things in my HDL expression, so automatically it will choose those Designware libraries, those components from the Designware libraries, which are that means like fully optimized. That means the multiplier, as I said, that the multiplier which are being already used, they will be reused. So, if I do not want to use my multiplier on my own, so at that time if I just mention that star that means assign that star, that means in HDL code, so automatically it will choose the multiplier block from the Designware library, and it will be converted based on my, that means parameters like whether that is what is the bus length of that. So, that will be now converted into the corresponding gate level netlist using the basic gates. Okay. So, that is the job of the Designware library. Okay. So, then physical library basically it is required for physical design aspects, that means it is used in IC compiler or this Milky Way environment. So, whenever we will use it, at that time it will you will see. So, this Milky Way technology file extension is that .tf. Okay. So, here you see that there are several comments So target library will be set as target underscore library, then your library dot db. That link library will be set as link underscore library, then your library name dot db. Symbol library will be set as symbol underscore library, then your library name and then dot hdb. Designware library is like dot sldb. Okay. So how you can set the other option, that means you can also link to the multiple library, so that also you can do. So how you can do that is that you can that means in the dcl command prompt you have to write this command, so automatically it will whenever you enter this command, so automatically it will be incorporated into the design compiler environment. So we will see that during the demo part. So and then this how this logic library you can specify using this command like set underscore app underscore var, then synthetic underscore library, then designware foundation dot sldb. Okay. So then as a link library also you can link by this command. Okay. So search path, how you can specify the search path. So set underscore app underscore var search underscore path along with the corresponding path name. Okay. So again, if you want to see that which library it is associated with, then you type which mylib.db. So it will show you that in which path this corresponding library is that means is placed. So then again we have to, if we want to set, that means this logic library basically comes with 3 module, like one is for minimum, another for, that means in 3 mode, one for minimum, another for maximum, and another case is typical one. So that means the maximum one is that means where all this information are, that means all this, that means about timing or this process variation or this voltage variation or the timing variation, that are on the higher side. So the minimum one on the lower side, the typical one is on the average side. Okay. So whenever we are designing an IC, so at that time I have to choose, that means I have to test it for the extreme condition, as that means extreme condition in both way, as well as the normal condition as well as the extreme condition, that means so that it can go to the maximum watt limit and minimum of watt limit it can varies. So within that range I can or I have to check my that means circuit's performance. Okay. So while I am that means providing this, the linking this library, or I am providing this corresponding target library information, so at that time I have to put all those information together to the Designware library. So then these are the comments for specifying the physical library, right? Like create underscore Milky Way lib underscore minus technology, Milky Way tech file. So this is this. So these are the comments which is basically used, which will be used in the tool itself. So that's why here then what is the meaning of telling this, that these are the like for creating the Milky Way target library. So this is the command like create underscore mw underscore lib, then minus technology, then give the technology file name, then again Milky Way reference library, give the reference library name. So this is the total command line for doing that. So it is not at all that all the time all this information is basically available in the GUI mode. You have to work with command line interface. So that's why what is the meaning of that. So whenever I'll show the demo, at that time it may be like surprised to see that okay, what is that meaning of this particular command. So here I am mentioning that okay, this particular command is basically creating the library for Milky Way environment. This particular command line is basically used for setting the target library in design compiler environment. So that's why I am just mentioning these things in this lectures. Okay. So then we have to mention this TLU plus files in Milky Way environment by using these comments. Okay. So this TLU plus files is basically needed for RC extraction. So RC extraction means the extracting these resistance and capacitance values. Okay. So this is the command line, like, and this is the ITF file. ITF file means this interconnect technology format file. So the corresponding command for that is set underscore TLU underscore plus underscore file minus max underscore TLU file, then max TLU files names, and then min TLU files with the min TLU file name, along with this take to ITF underscore map with the corresponding map file name. Where from I will get this TLU minimum TLU plus file or maximum TLU plus file or this Milky Way environment technology file, all this information will be provided by the corresponding technology vendors where I am going to fabricate my chip. So they will provide me all this library information. So from there, now my job is to set all this information in all these libraries in the corresponding environment to properly design the full ASIC of my circuit. Okay. So for today, this is it. Thank you.